Welcome to the deep dive. We're here to help you navigate this sea of information out there and really zero in on what matters. Today we're diving deep into artificial intelligence. It's huge, it's confusing sometimes, always debated, a world of amazing progress, but also, some real warnings. We pulled together quite a stack of material for this one key articles, research, our notes, and our goal today. Pretty simple. Cut through all that noise around AI. We want to get a handle on what it's built on, how it's changing things, and the big questions it's forcing us to ask about our future. We'll also look closely at those times when things didn't go so well, those AI winters when all the excitement kind of deflated.
That's exactly it. And what's really striking is how fast the whole story around AI changes. These sources we have, they're so valuable for helping us sort out the real breakthroughs from what you might call, AI snake oil. We're going to look at this from all angles, using these texts, the techie details, the massive societal shifts, those tough ethical spots AI puts us in. The idea is to give you a solid but hopefully easy to grasp picture of where AI is now, how it got here, its potential, and yeah, those critical questions we all need to think about. And like you said, that pattern of early hype followed by disappointment, that first AI winter especially, really shaped the field, taught some hard lessons about expectations and limitations.
Okay, let's jump right in, maybe with a bit of a reality check first. Because, for all the amazing AI stories, our sources, especially this book, AI Snake Oil by Narayanan and Kapoor, they point to this big problem. They call it the AI hype vortex. And it's not just like innocent enthusiasm, it's systemic. Researchers, companies, the media, they all kind of feed into this cycle of misinformation, building up these myths about what AI can actually do. Narayan and Kapoor are pretty blunt. They say broken AI can and does wreck lives and careers. That gap, between the big promises and what AI actually delivers, sometimes with flaws. We've seen this pattern before. In fact, that kind of unchecked hype was a huge part of why things went sour the first time around, leading straight into that first AI winter.
You've really hit on something vital there, and it links directly to one of the biggest, oldest challenges in AI. What do we even mean by intelligence when we're talking about machines? One of our sources, Empire of AI, asks this directly. Isn't there a solid definition that doesn't just compare it to humans? And the answer is, well, honestly, not yet. We just haven't figured out how to generally describe the kinds of computer processes we'd all agree are intelligent on their own terms. So what happens? Almost by default, we measure AI progress against what humans can do. Think about it. We say computer vision can see, NLP can read and write, speech recognition can hear, generative AI can create. It's all benchmarked against us. Now that makes sense intuitively, but it sets this constantly moving, incredibly high bar. And historically, that gap between the dream and the reality, especially with early AI, was a big factor in the disillusionment. Back then, if an AI couldn't hold a perfect conversation or reliably spot objects in different settings, it felt like a failure, even if it had made some real, maybe narrow progress. This constant human comparison, without a clear machine-specific goal, it's been both a driver and a source of frustration. And it definitely played a role leading up to that first AI winter.
That totally makes sense. If you don't know exactly what you're aiming for, it's easy to miss the mark, or for others to think you have. And it's not just about definitions, is it? The sources show these practical failures that just get buried under all the hype. AI Snake Oil lists 5 key reasons predictive AI fails. These are really important for anyone trying to understand this stuff. First, you can have a good prediction that leads to a bad decision. The book uses this example. An AI correctly flags asthma patients. Sounds good, right? But what if some of those patients also have pneumonia, and the AI's focus on asthma makes doctors send them home? The asthma prediction was good, but the decision, potentially disastrous. It lacked that wider context.
Right, it missed the bigger picture.
Exactly. Second, people figure out how to game systems they don't fully understand. This is fascinating. The authors mention automated hiring tools. People might learn, maybe online or just by trying things, that putting bookshelves in their video background helps their score. Not because they're more qualified, but because the AI somehow learned to associate bookshelves with good candidate from its training data. It's gaming a proxy, not showing skill.
It's finding loopholes in the algorithm.
Precisely. Third, and this is scary, users relying too much on AI without enough human oversight. There's that example from the Netherlands, the welfare fraud model. It wrongly accused, 30,000 parents. Operating without enough checks, it ruined lives, caused huge financial hardship. A stark reminder of the real-world impact when AI goes wrong, unchecked.
Devastating consequences.
And finally, number 4, which seems so common. The training data comes from one group, but the AI gets used on a totally different group. If you train an AI mostly on data from, say, one city or one demographic, and then use it somewhere completely different, well, its predictions are likely to be off or biased or just plain useless. These aren't sci-fi problems. They're happening now, affecting job applications, legal systems, often invisibly. And these kinds of limits, this gap between the promise and the reality, that's exactly what fueled the disillusionment of the first May I winter when those early systems just couldn't live up to the hype.
You've laid that out perfectly, how the technical flaws become real harm. And they're not just isolated glitches. These failures ripple outwards, connecting to bigger societal problems, often amplified by the systems themselves. Mark Zuckerberg, for instance, apparently suggested that social media amplifying problematic content is just a natural phenomenon. But Narayan and Kapoor, they strongly disagree. They argue it's a direct result of how the recommendation algorithms are designed.
So it's baked in.
Kinda, yeah. Think about how misinformation spreads. It's often not just blatant lies, it's more subtle. Like the book says, you take a small truth, a rare vaccine side effect, a single case of voter fraud, and then the algorithms push it, suggesting it's a widespread pattern. That's way harder to debunk or ban because it starts with something true.
Much more insidious.
Exactly. And what's really interesting, maybe worrying, is how the design philosophy leads to these outcomes. It makes you ask, if the system itself encourages this stuff, how do we actually make sure it's doing good? It's not just the content, it's the whole context, the impact. Even something like the Instagram selfie seems harmless, right? But the way platforms push engagement, encouraging social comparison, it can have a really damaging effect on teen mental health. You don't just ban selfies, obviously, but the mechanism that amplifies that kind of comparison points to a deeper issue. So this raises a big question. If these negative outcomes are sort of woven into the text design, how do we steer it towards real benefit? Especially when we remember how the failure to deliver on much simpler promises backfired so badly, leading to funding cuts and skepticism that stalled AI for years. It feels like a familiar pattern, just with newer tech.
Okay, so we've got the hype, the real-world problems, the historical echoes of disillusionment like the first AI winter. But to really get why AI struggles, and also why it's achieved so much despite that, we need to look under the hood, right, at how these systems are actually built. Let's trace that journey from early logic ideas to today's deep learning stuff. It goes way back, mid-20th century. People like Herbert Simon and Alan Newell back in '58 talking about heuristic information for problem solving. Like, instead of checking every single book in a library of brute force, you use heuristics, clever rules of thumb. Check nonfiction first, or look for authors starting with S. It makes the search smarter, more efficient.
It guides the search process.
Exactly. It let early AI systems move beyond these impossibly slow searches towards something more, well, intelligent. And we saw systematic search methods develop too, like breadth-first search, exploring all options at one level before going deeper. Think of mapping out all the streets at one intersection before exploring the streets off those streets. These were key for early game-playing AI, like Chess 4.5 back in '77. That used something called iterative deepening, basically, looking a bit further ahead in the game each turn to find the best move. Super advanced for its time. And this period was full of optimism, wasn't it? The idea that machines could think, play chess. It felt like human-level AI was just around the corner. But those systems, even the impressive ones, they were often quite narrow. They couldn't really generalize. And that growing gap between the promise and what they could actually do, that definitely fed into the disillusionment before the first AI winter.
And that gap became starkly, almost painfully clear with early neural nets. Specifically with this book, Perceptrons, by Marvin Minsky and Seymour Papert in 1969. This wasn't just some academic paper, it was huge, often pointed to as a major trigger for that first AI winter you mentioned.
Okay, so what was a perceptron and why was this book so damaging?
Right. Think of a perceptron as like the simplest possible artificial neuron. Takes inputs, adds them up, and if it hits a threshold, it fires. A basic switch. Early models had just one layer of these. Minsky and Papert mathematically proved that these simple, single-layer perceptrons, specifically diameter-limited ones, meaning their internal connections weren't too complex, they simply cannot recognize connectedness.
Connectedness, like seeing if a line is continuous.
Exactly. Can you tell if a drawing is one single shape or lots of separate bits, like a C versus two small arcs? Humans do it instantly. Minsky and Papert showed these simple perceptrons fundamentally couldn't make that distinction. It wasn't a bug. It was a core limitation. It suggested that real brains, animal brains, must need something more complex, than just adding up signals to understand even basic visual stuff.
Wow. So it hit a theoretical wall.
A hard wall.
Yeah.
And coming from two respected MIT AI figures, it was devastating for neural nets. The message was clear. These simple models can't handle complex, real-world problems like vision. Funding dried up, research shifted away. It was that hype vortex meeting hard science, and it really helped bring on the chill of that first AI winter. People just lost faith in that approach for quite a while.
Incredible. One proof basically freezes a whole research area for years, but eventually things thawed out. After that long winter for neural nets, we got deep learning. And it came from this insight that sounds simple but was revolutionary. Having more layers, depth improves accuracy. Just stacking more processing layers could unlock way better performance. That's what brought neural nets back.
It allowed for more complex representations.
Right. And the ImageNet competition really showcased this comeback. Around 2010, 2011, the winners used older methods, like SVMs. Their error rates, still pretty high, like over 25%. Good, but not game-changing. Then, 2011. This team, Alex Krzyzewski, Ilya Sutskever, who later co-founded OpenAI, and the legendary Geoffrey Hinton, they decided to try ImageNet with these deep neural networks, specifically a convolutional neural network. Hinton had actually published the core algorithm backpropagation way back in '86. But now, computers were faster, there was more data, the time was right. Their system, AlexNet, just crushed the error rate. It wasn't a small step, it was a massive leap. It totally changed how people saw neural nets, proved that depth worked, and effectively ended that particular winter.
Yeah, AlexNet was a landmark, and its success relied on several key technical pieces falling into place. Central was backpropagation, which, as you said, Rumelhart and others formally described in '86. Think of backprop like the network's learning coach. It sees an error, oops, called that cat a dog, and sends that error signal backwards through all connections. As it goes back, it calculates the gradient for each connection. It's basically a precise tweak. Adjust your strength this much, in this direction, to fix this error. It's how the network learns, step by step, from mistakes.
Fine-tuning itself constantly.
Exactly. Then you had breakthroughs in architecture, especially convolutional neural networks, or CNNs, tailor-made for images. Imagine tiny filters, kernels, scanning the image, looking for edges, textures, corners. Different layers learn increasingly complex features. Little tricks like zero padding, adding blank pixels around the edge were important too. They stopped the image shrinking too much as it went through layers, preserving info.
Ah, clever.
And the power of depth just kept getting clearer. Models like VGG showed just adding more layers, even simple ones, boosted accuracy. Then ResNet tackled a huge problem. Super deep networks were hard to train, gradients vanished. ResNet added residual connections like shortcuts, letting information bypass layers. That allowed networks hundreds of layers deep. And inception models added width, processing features at multiple scales at once. These aren't just abstract maths. They're why your phone can recognize faces and objects so well now. A universe away from the limits that caused the first AI winter.
And it just kept accelerating, didn't it? Into the 2020s, we get large language models, LLMs, and the transformer architecture. The scale is just mind-blowing. GPT-3, Google's PaLM with 540 billion parameters, Microsoft NVIDIA's Megatron Turing NLG with 530 billion, even experimental ones like Switch Transformer hitting trillions of parameters. Think of each parameter like a tiny connection, a bit of knowledge, trillions of them. That's how they grasp such complex language patterns.
The scale is astronomical.
And here's where it gets really cool, showing that iterative innovation. The transformer, the T in GPT, was built for text, for sequences of words, but then came the vision transformer, or VIT. It took that powerful text architecture and applied it to images. How? By cleverly splitting the image into patches, treating each patch like a word. So it processes image chunks sequentially, just like words in a sentence. Suddenly, the architecture that revolutionized language could conquer vision, too.
A really elegant transfer of ideas.
Totally. And OpenAI pushed this multimodal idea further with CIP contrastive language image pre-training. CIAP trains image and text understanding together, so it learns to link a picture of a cat, not just to the word cat, but also concepts like pet, feline, maybe even breeds. Going from those early perceptrons that couldn't even see connectedness to these giant models understanding language and images, it's just an incredible journey of building on past ideas, overcoming old limits.
Okay, let's zoom out from the tech itself and look at AI's footprint. How it's changing, well, everything. Starting with jobs. The story always seems to swing between, robots take all jobs, doom, and AI creates utopia hype. But the sources suggest something more. Nuanced. AI snake oil puts it well. They don't expect sudden mass unemployment, but AI will change jobs. Some demand goes down, some goes up. New kinds of jobs even appear. It's a shift, maybe faster this time.
A restructuring, yeah. But the key thing is, for people whose jobs do get automated away, the outlook can be scary, as the book says. They need new skills, maybe help bridging the gap financially while they retrain. And prediction machines adds this layer about technology being skill biased, meaning it tends to boost wages for highly educated folks who can adapt more easily, while maybe hurting wages for less educated people doing routine tasks that AI can learn.
Widening the gap potentially.
Yeah, think about that London taxi driver example. Their deep knowledge of the streets, their skill, was devalued by GPS and prediction algorithms used by Uber. But those same algorithms created more jobs for Uber drivers, even if often lower paid with less security. So it's not just jobs lost versus jobs gained. It's about how we manage that transition, how we support people. It's a big societal question.
A huge one. And that idea of preparation leads right into education. AI there is moving past the robots replacing teachers. Fear towards being this really powerful partner. Look at Khan Academy's Khanmigo AI tutor. Sources say it can explain stuff, obviously, but also analyze why a student is struggling, pinpointing misunderstandings like a human tutor might. It can even answer that classic student question, why do I need to learn this? By connecting, say, biology concepts to a football player's diet makes it relevant.
That's pretty cool, personalized relevance.
Exactly. And Brave New Words points out a big psychological plus. AI tutors remove that specter of potential public shame. Students feel safer asking questions, any question, without worrying about looking silly in front of classmates or the teacher. That encourages curiosity.
Takes the pressure off.
For teachers, too, the potential is huge. AI is an assistant for planning, grading, giving feedback, freeing them up from the admin grind. It can help manage group work, let teachers focus on the human stuff, mentoring, inspiring, building critical thinking. So what's fascinating is this shift in thinking. Not AI replacing teachers, but AI as a trusty wingman, enhancing what humans do best in the classroom. It's about augmenting, not replacing. A partnership.
That partnership idea seems key. And we see AI embedding itself elsewhere too, right? Consumer products, big business strategy, often subtly. Take self-driving cars. The core idea shifted from writing rules for every situation impossible to prediction. What would a human driver do here? AI learns from millions of miles of human driving data to predict actions, traffic, make decisions. And this cheap, powerful prediction makes other things more valuable than complements, like sensors. That's why Intel paid $15 billion for Mobileye, which makes sensors and collects driving data. Prediction makes the data gold.
The value shifts.
Totally. Or think about Amazon's anticipatory shipping patent from way back in 2013. The idea: use prediction to ship stuff to a hub near you before you even buy it, shifting from shop then ship to ship then shop. It hasn't fully happened, maybe because returns are costly, but it shows how prediction can fundamentally change business models. And looking forward, AI 2041 sketches this future. AI assistants guiding us, AI doctors diagnosing better, AI entertainment becoming hyper-realistic. It's a fundamental shift in daily life.
And this deep integration really highlights what Ethan Mollick calls co-intelligence in his work. Mollick argues AI is most valuable when we treat it like a partner, a co-intelligence, not just a tool for automation. He actually says, invite AI to everything you do. Not to take over, but just to learn what it's good at, where it messes up its limits.
Learning its strengths and weaknesses firsthand.
It's excellent. He talks about the jagged frontier of AI. It's brilliant at some things, terrible at others, very uneven. As you get used to this jaggedness, how you use AI evolves. Maybe you start as a centaur like the human AI chess teams. You give AI the tedious tasks you hate, the ones you can easily check, like drafting a standard email. But then you might move to being a cyborg. AI becomes indispensable, an extension of your own thinking, helping with tricky, creative stuff. It's not just doing tasks for you, it's working with you, helping you brainstorm, overcome mental blocks, synthesize information. It's about leveraging AI speed and pattern matching to boost our own creativity, a symbiotic thing where both human and machine do better together than either could alone.
Okay, but with all this power comes, well, a pretty big ethical minefield we have to navigate carefully. Bias is a huge one, right? Our sources really hammer this home. There's that example of predictive healthcare models. Even without using race directly, they ended up recommending less proactive care for Black patients. Why? Not because the AI was programmed racist, but because the data was biased. It reflected historical underinvestment and disparities in healthcare for Black communities. The bias was baked into the historical data it learned from.
You learn the existing societal biases.
Exactly. And it connects to that point from AI snake oil. Training data from one group gets used on another. If the training data mostly reflects one demographic's healthcare, using it on another group just perpetuates those historical biases. So What does this mean for you listening? It means even objective AI can amplify inequality if we're not super critical about the data. It can creep into loan applications, hiring, even medical diagnosis, often invisibly extending past injustices. Technology isn't neutral when it learns from a biased world.
Absolutely. And bias is just one piece of the ethical puzzle. There are so many other challenges: privacy, surveillance, job displacement. Atlas of AI talks about AI's massive appetite for data, how it harvests publicly accessible digital material, including personal, potentially damaging stuff for training. Think about it. Massive data sets full of our selfies, hand gestures from videos, recordings of babies crying, old forum posts, all scraped and used to train AI for facial recognition, language prediction, object detection.
Just raw material stripped of context.
Precisely. When personal data becomes mere infrastructure without consent or context, it raises huge ethical flags. It fuels surveillance capitalism. And like Tenenbaum points out in Architects of Intelligence, these aren't future worries. He says privacy issues, job displacement, misuse of algorithms, these are immediate concerns, much more pressing than hypothetical superintelligence takeovers. These are happening now.
And yet, that superintelligence debate is happening, and it's unsettling. It's not just sci-fi anymore. You have people like Geoffrey Hinton, a godfather of AI, leaving Google partly to warn about the dangers, even suggesting humanity might just be a passing phase in intelligence evolution. It's stark. It feeds into this idea of the probability AI leads to human extinction, which then leads to calls for urgent regulation.
It's a heavy conversation.
It is. And you get even more provocative ideas. Larry Page from Google reportedly feeling that humans insisting on controlling AI is speciesist, biased against non-human intelligence, even suggesting AIs might be our rightful heirs.
Right.
Or Richard Sutton saying AI succession is inevitable and we shouldn't resist it. These aren't fringe voices. They're pioneers raising fundamental questions about our future, our very existence. It's deeply uncomfortable stuff to grapple with.
And those extreme scenarios really shine a light on maybe the most critical, technical, and ethical problem: aligning AI goals with human values. Stuart Russell, in Human Compatible, makes this brilliant point. If the goal we give an AI can be flawed or have unintended consequences, it makes no sense for the machine to act as if it is always correct. If an AI just relentlessly pursues a flawed goal we gave it, the results could be catastrophic precisely because it's so efficient.
The sorcerer's apprentice problem, almost.
Kind of, yeah. Russell proposes we shift to building beneficial machines. Machines that don't just follow orders, but learn our preferences and values from our choices, and importantly, defer to us when they're unsure. He uses that vivid example: a domestic robot told to feed the hungry children. If it knows the cat is nutritious but has zero understanding of sentimental value or social taboos, well, you see the problem.
Oh, wow. Yeah. Feed the cat to the kids. Yikes.
It perfectly shows how simple goals plus lack of context or values equals disaster. So this forces the question: how do we bake our values, not just instructions, into these machines? How do we prevent these catastrophic unintended outcomes as AI gets smarter? It's about making sure the AI's purpose truly serves us, not its own perfectly logical but totally misaligned interpretation of our commands. Otherwise, you risk that intelligence explosion scenario where its alien goals just win.
And governing all this, it's incredibly complex. You've got different forces pulling in different directions. Some, like Nick Bostrom, push for safety research, but think regulating superintelligence now is premature. Maybe it stifles needed innovation. Yet inside companies, you see internal governance measures, ethics codes popping up. So there's some recognition of the need for guardrails.
Acknowledging the problem, at least internally.
Right. But then there's this worrying creep toward less transparency. That GPT-3 paper example, winning awards but not detailing how it was trained, that makes it really hard for outsiders to scrutinize it for bias, safety, or even just replicate the work.
Box independent verification.
Exactly. And add to that what the sources call multi-human dynamics. Basically, competition companies against companies, nations against nations, pushing everyone to develop AI faster and faster. This could lead us to hand over power to AI systems without proper checks just to stay in the race, as Introduction to AI Safety warns. We could end up tolerating huge risks, potentially making ourselves a second-class species. Who controls it? What values guide it? How do we balance progress and safety? These are massive, open, urgent questions. Okay, let's try and pull this all together now. We've really journeyed through AI's landscape, the hype, that AI hype vortex, the hard lessons from the first AI winter. Then we dug into the tech itself, from early search ideas, the limits shown in perceptrons, up to the deep learning revolution with backprop and transformers powering today's huge models. And we saw how this tech is deeply impacting jobs, education, business strategy, weaving itself into our lives, raising that idea of co-intelligence.
Absolutely. It's been this story of big dreams hitting tough realities, hasn't it? Where innovation keeps overcoming old limits, but then reveals new, maybe even harder, challenges. From those early winter failures to today's ethical knots of bias and existential risk, AI is clearly not static. It's evolving incredibly fast. And hopefully this deep dive shows that talking about AI isn't just for tech gurus. It's a conversation for all of us. We need to be co-intelligent with the technology, but also critically aware, moving past blind optimism or total fear toward thinking carefully about what AI can and can't do and how we steer it towards a future that actually benefits humanity, learning from those past winters. And as you mull all this over, here's a final thought to chew on, something people like Demis Hassabis have theorized about. What if intelligence and consciousness really can be separate? What if machines can become incredibly superhumanly intelligent, but never actually be conscious in the way we are? If that's possible, what does it really mean to be human in a world increasingly filled with, maybe even run by, non-unconscious but highly intelligent entities?
It's a deep question about our own place in the future.